So these are the signals we have already seen. Now they have written a Verilog code for this APB ASB to APB bridge. So you see here they have written input port they have defined, in outputs they have defined, output ports they have defined. Then they have used def speed sim. If you want to increase the speed of the simulation, they are using cycle based simulators. Okay. Else they are using this event based simulators. Okay. So you see how they have created actually they have implemented somewhere clock generator, and they are including that instantiating that clock generator here. Whereas if you take example of cycle based simulators, what they are doing, they are running they are writing the behavioral model inside the module and running it. Okay. Now they have you see data type declarations are there. Okay. So this is the you don't concentrate on the functionality how they have decoded. Okay, just concentrate how it is working, how they have designed the things. So they have used assign statements and as b error, all those things. Now size, based on the size they are assigning the values, right? So this is one thing. Then they are talking about assignment for APB data bus, ASB data bus depend upon the bus size. Based on bus size they are allocating the size. Okay, so this is simple APB interface. You just go through it. So this is an RTL, full RTL. Now coming to the test bench. Now we are using test bench for event based simulators. So test bench is a top module where you need there is no ports. Okay, so that is why there is no port list in the test bench. Now they are having data type declaration. Now you are instantiating that bridge. Now you are instantiating the bridge here. So these are the you are instantiating by name, instantiation by position you are doing here. Then initially you are making reset 0, and after that you are making 20 time unit reset 1. Okay, then you are forcing some address here BA. Then you are displaying that thing. At last you are stopping the simulation. So this is one simple test case. Now when you run this simulation, okay, so what will happen? So you are calling this module and you are running the simulation. The simulation is a run on the ASB APB bridge RTL design using Cadence NC Verilog. Actually they are telling that they have used NC Verilog in order to run the simulation. So running the Cadence NC Verilog tool on ASB APB bridge RTL design using a test bench gives the following results. So the following results is the module 2 unique to registers. They are telling 17 registers scalar wise. So this is a consolidated summary you will get. Okay, initial blocks they are telling 2 initial block always, like this type of messages you will get. Then they are telling after going to this window, NCSIM window, like when you are okay, if I will compare this thing with model sim, means when you are writing vsim, so what will happen? You will go to model sim prompt, right? So similarly here when you write NCSIM you are going to NCSIM prompt. So after that you will run it will display the value. Why it will display? Because we have used display here, right? So it will display the value here. So the result can be analyzed using waveform viewer incorporated